Welcome to this explainer. Today, we're taking raw, chaotic datasets and transforming them into absolute masterpieces using Python's Pandas library. If you've ever stared at a spreadsheet that practically crashes your computer just by scrolling and wondered how to make sense of it all, you are in exactly the right place.
To keep things super simple, here's our roadmap. We'll meet your new data superpower, break down the building blocks of Pandas, import and explore some data, do a little slicing and filtering, clean up the mess, and finally, analyze and save those results. Let's jump right in.
Section 1. Meet your data superpower. So, what exactly is Pandas? Think of it as a magic wand for structured data. It's an open-source Python library built right on top of NumPy, and it's specifically designed for high-performance data manipulation. Whether you're pulling together basic business reports or prepping data for some heavy-duty machine learning models, Pandas is your essential first step. Imagine trying to sort a spreadsheet with 10 million rows by hand. Your computer would literally freeze. Pandas handles that heavy lifting in milliseconds.
And getting this superpower set up, it literally takes 2 lines of code. Step 1, you just pop open your terminal and run pip install pandas. Done. Then, step 2, inside your Python script, you just type import pandas as PD. We use that little PD alias just to save ourselves some typing later on. It's the absolute industry standard, so you're going to see that shorthand everywhere. Moving on to Section 2, the building blocks of Pandas. The whole foundation of Pandas rests on 2 main structures. First up, you have the series. You can think of a series as a one-dimensional labeled array. Basically, it's just a single flat column of data, like a long list of ages or a list of cities. But then you step up to the big leagues with the DataFrame. A DataFrame is a 2-dimensional table with rows and columns. It's essentially a full-blown Excel spreadsheet built directly into your Python code, allowing you to cross-reference multiple series at once. To put that into perspective, picture a clean, structured grid. You've got neatly organized rows and columns containing student or employee records, names, ages, and cities. So you've got Alice, 22, from New York, and Bob, 25, from London. This clean grid is exactly how Pandas visualizes and holds our data behind the scenes, which makes it incredibly intuitive to work with as we move forward.
All right, Section 3. Importing and exploring your data.
Let's be real, you're not going to be typing out massive datasets by hand. Now, while you definitely can pull data from JSON files or directly from SQL databases, CSV is the undisputed industry standard, and bringing it in takes just one quick command. You literally just type pd.read_CSV and drop in your file name. Working with Excel, pd.readExcel works exactly the same way. Boom! A file with millions of rows is loaded and ready for action. No waiting for loading screens, no crashing.
Before diving into deep analysis, you'll want to get the lay of the land using a few basic exploration commands. Calling .head lets you peek at the top 5 rows, while .tail shows you the bottom. The .info command is an absolute lifesaver for checking data types and spotting missing values right off the bat, and .describe instantly generates a high-level statistical summary. You can even just use .shape to see exactly how many rows and columns you're dealing with. It's literally like turning the lights on in a dark room.
Section 4. Slicing and filtering data.
You rarely need to look at your entire dataset at once, right? So, you can slice out specific columns just by calling their names in brackets, like df bracket quote name. Or, if you need specific rows, you can use .loc to search by text labels, kind of like looking someone up in a company directory. Or use .iloc to grab rows strictly by their numerical positions. It gives you absolute surgical precision over your dataset.
But where Pandas truly shines is Boolean filtering. Say you need to find everyone living in Mumbai instantly. Just use a simple equals check. Or maybe you want to filter your massive table down to only people older than 23. You just type df brackets, quote, age, greater than 23. It instantly grabs only the rows that meet your exact practical conditions. It's incredibly fast and completely logical.
Next up, Section 5. Cleaning up the mess.
Because here's the harsh reality. Real-world data is almost always messy. Imagine you're trying to calculate an average age for a critical business report, but half your rows are completely blank. Or maybe a server glitch logged the same user twice. This is exactly why data cleaning is the most vital step before any actual analysis happens. Remember, if you put garbage in, you are absolutely guaranteed to get garbage out.
Luckily, with just a handful of commands, you can do the exact same pre-processing work used in top-tier machine learning models.
Instead of hunting for blanks manually, .isNull finds them for you instantly. From there, you can ruthlessly delete those bad rows with .dropANA, or patch them up by filling the blanks with 0 using .fillInA0. And finally, .dropDuplicates just scrubs away any repetitive rows. In moments, your data goes from total chaos to pristine.
And finally, Section 6, Analyzing and Saving Results.
Okay, so your data frame is perfectly clean. Now you can run basic statistical methods on any numerical column to instantly calculate averages, maximums, minimums, or totals. We're talking about summarizing thousands or even millions of rows in a fraction of a second, completely removing the need for any tedious manual calculations.
Just by running one tiny command like df bracket quote age.mean, you dramatically extract an instant, tangible result from all that raw data. For example, discovering the average age of your users is exactly 23.6. It is incredibly satisfying to transition from a giant wall of intimidating numbers to one clean, actionable insight.
So why does this all matter? Well, this incredible speed, combined with the ability to handle massive data sets efficiently, is exactly why Pandas remains the undisputed industry standard. If you eventually want to build machine learning models, predictive algorithms, or dive into AI, Pandas is the foundational tool you need because it seamlessly integrates with heavy hitters like scikit-learn and TensorFlow.
To wrap up the entire workflow, you simply export your perfectly processed data frame back into a new CSV or Excel file, ready to be shared with the world or fed into another program. By using .2CSV or .2Excel and just setting index equals false, you ensure your final file is beautifully clean without any messy, unnecessary row numbers trailing along.
Congratulations, you've just mastered the foundations of Pandas. But think about this for a second. Every major AI breakthrough, every market-predicting algorithm, and every stunning data visualization out there relies entirely on the exact kind of data preparation we just did today. So what hidden insights are waiting in your messy data sets, just begging to be discovered? Keep practicing these core steps, and I'll catch you in the next explainer.